The average amount of money spent by Amazon Prime members in 1 year is $2,486. The standard deviation for these amounts is $1,500. If a random sample of 37 Amazon Prime members is selected, what is the probability that they have spent an average of at least $3,000 at Amazon this past year? All right, so this is a probability question, but it's a probability question that is asking about the location of a sample mean, right? And they want to know what's the probability that the sample mean is at least $3,000. That's 3,000 or more, by the way. Remember, the phrase at least means that number is the minimum, right? So 3,000 or more, right? Like if I said you need at least a C in this class to pass, we're saying you need a C or higher. So if I say at least $3,000, I mean $3,000 or more. Okay, so they're asking us for the probability that a sample mean because it comes from a sample of 37 randomly selected Amazon Prime members, they're asking for the probability that a sample mean is at least $3,000. The only rule we learned that deals with that is the theorem that we learned called the central limit theorem. It tells us that when the sample size is sufficiently large, sample means will fall on a bell curve, right? They will follow a normal distribution, or at least an approximately normal distribution. For our purposes, though, we can just assume it's a normal distribution, right? If it's approximately normal, we'll model it by the normal distribution. So we'll draw a bell curve, right? So let's draw a bell curve, and then we'll say, hey, because of the fact that they said we're dealing with a sample mean and the sample size is over 30, we can safely assume that the data is at least approximately normal. Now from here, we're going to go ahead and write in what we normally do when working with a bell curve. We need a mean, right? And then we're going to need a standard deviation. But be careful, this is a mean for the sample means and the standard deviation for the sample means. Luckily, the mean for the sample means is the same. We don't have to do anything there. We just take the mean that they gave us. They said the mean was $2,486, so I'll do 2,486 at the bottom here. The standard deviation, they say, is 1,500. However, that is not the standard deviation we will use here. That is just a start, right? Because when you have the standard deviation for x bar, you have to divide it by the square root of n. Now basically, working with the bell curve here is going to be the same as working with the bell curve in those previous problems where we used it to find probability. The only difference is that here, this number line at the bottom is not x, it's x bar, and therefore we have to have a standard deviation for x bar. So the only real difference is really the x bar and the fact that the standard deviation for x bar is not the same as the standard deviation they gave us. It's going to be that standard deviation, right? The standard deviation that they gave us is 1,500 here, divided by the square root of the sample size, which is 37. So that's the major change, right? That we have to take 1,500 and divide it by the square root of 37. So let's go ahead and do that. Let's take 1,500 and divide it by the square root of 37. So you get 246.59841. So 246 point, and then I'm going to use all the decimal places. 598,481. 598,481. Do you have to use all the decimal places? No, but I recommend you use at least 4 or 5, or store it in your calculator so you have it, right? In fact, that's what I'll do here. I'll store that in the calculator. So I'm going to store that as x, okay? So we'll remember that we have it stored. Okay, but the reason why we want to do that is we want to make sure that we're not rounding before the final step of the problem. Okay, now with that standard deviation adjusted, because we're dealing with a sample of 37, right? Once that's taken care of, then the rest of the problem is just like we used to do. So we're going to figure out where this $3,000 would be located on my number line. It would be on the right-hand side because it's larger than the mean. Then I would draw a line indicating where that occurs. And since it says at least 3,000, we're looking for the probability that it's 3,000 or more, right? So we're trying to find the area of this part of the curve. And then I have to convert that 3,000 into a z-score. And so we're going to use the z-score formula to do that. Z is equal to just the normal thing, right? Normally be x minus the mean over standard deviation. Here it's technically x bar minus the mean for x bar divided by the standard deviation for x bar, but that really isn't important. What really matters is that the number we want to convert is 3,000. That goes first. And we subtract off the mean, which we know is 2,486, right? Or 2,486. And then we divide by the standard deviation, which we wrote down as 246.598,481. Okay, let's work that out in our calculator and see what it gives us. So again, I've stored that denominator already in my calculator as x. So all I have to do for the top is just say 3,000 minus 2486 divided by that saved standard deviation. And when we're done, we get 2.08 if we round to 2 decimal places, so 2.08. And then we'll look up that z-score. It'll give us the area from here to here. That's not the area we want, but we can use that to get the area we do need. So let's look up 2.08. So let's look up 2.08. We'll go to the 2.0 position and then over to where 2.08 would be. It'd be next to last, right? So it'd be this number. So 0.4812. So 0.4812. Well, that's not the area we want, but we can get the area we need by just doing 0.5 minus 0.4812. Because remember, the whole half of the curve is 50%. If we take away the part here in white, we'll be left with the part we need. 0.0188, and that's your area for that tail shaded region. And that means we have a 1.88% chance of that occurring.